welcome to the IPC lecture series. Today we will continue our discussion of solutions by focusing on the pH scale. The term pH scale should be familiar to most of you, as it has probably come up within the confines of another science class that you have taken before IPC. Before we get into the nitty-gritty, I want you to keep in mind that the pH scale is a comparison of opposites. On one end is acids, and on the other end is bases. They react and sometimes behave very differently. They also can react with one another to neutralize, which forms salt and a water. Now, most of that should be review if you have sat through my lecture on acids and bases. If you have not seen the acids and bases lecture, stop this video and load up the lecture on acids and bases. Still with us? Good. Today we'll be taking a deeper look at the makeup of the pH scale. On this slide, we have a representation of the pH scale. I know there's a lot going on with this slide, but I promise I will break it all down for you. First, you need to notice that the scale goes from 0 to 14, with 7 being the midpoint. Second, you should notice that your acids are lower in number and get stronger as they decrease in number. We will talk more about strength in just a second. Your bases are the opposite. As their pH numbers increase, so does their strength. Third, you will see that we have illustrated the scale with a color gradient or color spectrum. Acids tend to be reds, pinks, oranges, or sometimes yellows, while bases tend to be greens, blues, or sometimes purples. Lastly, I want you to look at all the numbers. Notice that they are increasing or decreasing depending on what direction we are going up the scale. These numbers are the most important aspect of the pH scale. What are those numbers actually measuring, you ask? The answer to that is they are measuring the concentration of H+ ions. Simply put, this concept is the H part of the pH scale. You see, H+ ions can float around in solution until they find another ion that wants to bond with them. In this case, that would be its opposite, the hydroxide ion, or the OH ion. H+ and OH combine to form water, and if you were paying attention during the acids and bases lecture, you would know that when we neutralize an acid with a base, that one of the products is water. Now I want you to look only at the acid portion of the pH scale. Here you will see that the numbers on the pH scale are decreasing as we go up the scale. That means that the acid decreases its pH number, but is actually increasing in its strength. How much stronger, you ask? 10 times stronger. But how do I know that? Well, it's these numbers that let me know the strength of the acid. These numbers are increasing as the pH numbers are actually decreasing. They are increasing by a factor of 10 at each pH number. Again, you ask why? The answer is because the increasing numbers are the actual concentration of H+ ions in a specific amount of solution. I'm not going to go into detail about how we know this. I will leave that for next year when you take chemistry. For now in this class, I just want you to accept them and understand how they are related and how they function within the pH scale. So let's look here at neutral. Neutral starts at X, or in this case, really 1. This is because there are equal amounts of H+ ions and OH ions present in solution. That means that they will combine to form water and leave no free ions in the solution. As we increase to a pH of 6, we now have 10 times the amount of H+ ions present as we have OH ions present. This continues by a factor of 10 each number that we decrease in pH. A pH of 5 would mean 100 times more H+ ions. A pH of 4 would mean 1,000 times more. A pH 3 would be 10,000 times more, and so on and so forth. The reason that this is important is that H+ ions are very reactive. If enough H+ ions are present in solution, they will react when they come into contact with other materials. A good example of this is when acids come into contact with metals. Acids tend to react vigorously with metals. You would often hear the term dissolve used to describe this process because if the acid is strong enough, it looks like it eats or dissolves the metal away. That is why when cooking with stainless steel, it is a good idea to avoid using acidic foods. If you have to use acidic foods like tomatoes, you need to make sure you wash out the pot or pan after eating. You definitely don't want to leave the acidic food in the pot or pan overnight, as it can start to take the finish off the stainless steel. But what about our bases? Well, bases, in regards to metals, tend to behave in a similar fashion to acids. The OH ion is highly reactive, and the bases tend to react vigorously with metals just like acids do. But when looking at bases on the pH scale, you have to keep two things in mind. One, that bases have a high concentration of OH minus ions. And two, the pH scale is a measurement of the H plus ions. So what does that mean? Remember that H plus and OH minus ions combine to form water, and if there is more OH minus ions present, then the likelihood of having an H plus ion is very small. We show this with these numbers. As the pH increases, the percentage of H plus ions, shown in decimal form here, decreases. You just have to understand that if the concentration of H plus ions drops below 1, then that means that there are more OH minus ions present than H plus ions. I know that I hit you with a lot of information. Who knew that one slide can contain so much useful information? It is because the pH scale is important to understanding the behavior of acids and bases that I've devoted so much time to this one slide. So to summarize, pH scale is the measurement of the amount of H plus ions present in solution. The pH scale goes from 0 to 14, with 7 being not only the midpoint, but being the neutral. The lower the pH number, the stronger the acid, and the higher the pH number, the stronger the base. Also remember that H plus ions combine with OH minus ions to form water. This is how they neutralize. I hope you now have a better understanding of the pH scale and how it functions. Remember that if you are still struggling with this, that you can come to my tutorials Monday and Thursday mornings from 7:10 to 7:40. Until next time, this has been Mr. Messler with your friendly neighborhood IPC lecture, signing off.